Hi everyone. Today we're going to talk about Ohm's law, a fundamental law in electricity. We'll learn how voltage, current, and resistance work together. We'll look at examples from our daily lives. We'll find out why a light bulb might be bright or dim, and why one phone charger works quickly while another is slow. By the end of this video, you'll know how to apply Ohm's law in your everyday life. Let's get started. Ohm's law helps us understand how voltage and resistance affect the flow of current. Imagine a plumbing system. Voltage is like the water pressure in a pipe. The higher the pressure, the faster the water flows. Current is like the speed of the water flow. The more water flowing, the stronger the current. Resistance is like a narrow section in the pipe. The narrower the pipe, the harder it is for the water to flow through. The formula for Ohm's law is V equals I multiplied by R, where I is the current measured in amperes, V is the voltage measured in volts, and R is the resistance measured in ohms. The current increases as the voltage increases and decreases as the resistance increases. Let's look at some everyday examples. Imagine a flashlight and batteries. New batteries mean a strong current, and that means a bright light. Old batteries mean a dim light because the current is weak. Another example is charging your phone. A good charger has low resistance and charges your phone faster. A bad charger has high resistance, which means it charges your phone slowly. Let's see how we can use Ohm's law in our homes. If you have a device with a known resistance, you can calculate the current it will draw at a given voltage. This is helpful to prevent overloading circuits in your home. For example, a heater with a resistance of 20 ohms at a voltage of 220 volts will draw 11 amps. We divide the voltage by the resistance of the device. Knowing the current capacity of your wiring helps you decide if it's safe to plug in the device. You can use Ohm's law to choose the right extension cord. Knowing the power and voltage of your electrical system, you can calculate the current. For example, a device with a power of 2000 watts will draw 9.1 amps. Divide the power by the voltage using Ohm's law. Make sure the extension cord is rated for that current. Saving energy is also related to Ohm's law. Using devices with different resistance affects energy consumption. A light bulb with high resistance consumes less current and energy than a light bulb with low resistance at the same voltage. Use batteries correctly. When building devices, it's important to consider resistance to avoid overloading the battery. For example, for a 12-volt battery and a current of 2 amps, the resistance should be 6 ohms. Knowing Ohm's law helps us understand why devices can get hot or overheat. If the current is too high, the device may overheat, which can lead to damage or even a fire. These examples show how understanding Ohm's law helps us in everyday life, ensuring safety and efficiency. The more electrical devices we own, the more important Ohm's law becomes in our lives. If you like this video, please give it a thumbs up and subscribe to our channel. Thanks for watching, and see you next time.